Assalamu alaikum. So today is the last day for carbonyls, and that doesn't mean that we won't be reviewing these or coming back to these. Of course we will. We are going to start carboxylic acids after this, and that builds heavily on this one. But it's important to know that whatever the major concepts are in this chapter, how they relate to alkenes, alkenes, carboxylic acids, halogen alkanes, hydrocarbons, all of that. And then we also need to know how we can make use of these concepts that we have studied. So today, this is a very comprehensive worksheet, and I hope that we will be reviewing all the concepts that we have studied so far. So let's get started. Samples of the following compounds were labeled A to E. Let's see. This one is an alcohol. The second is a secondary alcohol. So this is a primary alcohol and secondary alcohol. We know primary alcohols oxidize to aldehydes if you distill them, and if you reflux them, then they oxidize to carboxylic acids. Aldehydes themselves also oxidize to carboxylic acids. Similarly, B is secondary alcohol, so if you oxidize it, it will convert to ketone, but can't be oxidized any further. C is an aldehyde, it has CHO group, which means it can be oxidized to carboxylic acids, can be reduced to alcohols. D is a ketone, can be reduced to secondary alcohol. And E is an alkene, which means it can be oxidized in cold temperature to make diol, and in hot temperature to make to break the double bond and form, this is secondary carbon, so it will be aldehyde, and then that aldehyde can also be further oxidized to make carboxylic acid. And there will be two similar structures because this is a symmetric alkene. Alright, so having that in mind, let's get started. Reagent is acid by potassium dichromate, which is strong oxidizing agent, green color obtained on boiling. Of course, that's oxidation. So A can be oxidized, B can be oxidized, and C can be oxidized. Acid by potassium manganate is also a strong oxidizing agent, and ethanoic acid is obtained. That means you're getting ethanoic acid, so that should be C. Okay, and you're also heating it, it's boiling, right? So E will also break down and give us ethanoic acid, because first it will form ethanol, and that ethanol will form ethanoic acid because you will break it from over here. Okay, so C and E. Hydrogen in the presence of a platinum catalyst. Hydrogen in the presence of platinum will reduce the thing, especially the one with double bond, so that's going to be E. You will get butane from that. Valence reagent, it goes blue to red, and that's because it has copper 2, but then it goes to copper 1 because it's a weak oxidizing agent. So weak oxidizing agents work on aldehyde, so this is going to be C. 2,4-DNPH tests for the presence of a carbonyl group, and if there is a carbonyl group, it goes orange, so that's going to be aldehyde and ketone. Bromine in an inert solvent, so solution decolorized, that is a test for double bond, so this is going to be E because it can saturate the compound. Okay. A compound A has the following composition by mass. Okay. It has an MR of 72. Let's figure it out. So we'll just list all of that. Carbon, hydrogen, oxygen, 66.7, 11.1, 22.2. Divide that all by their ARs, not MRs, ARs. And that gives me 5.5, 11.1, 1.388. Divide them all by the smallest number, so that gives me 481. So C4H8O1. And what's the MR of this thing? This is 48 plus 8, that's 56. 56 plus 16, that is 72. So yeah, this is actually the answer. A reacts with 2,4-dinitrophenyl hydrazine. This is the compound, it reacts with 2,4-DNPH, but not with Fehling or Tollens reagent. Fehling's or Tollens reagent react with aldehydes. They're mild oxidizing agents. So this is not an aldehyde, that's what it says. And it is reacting with the 2,4-DNPH, which means it has to be a carbonyl. So the only option that we have left is ketone, so this will give us orange precipitate, and it has ketone. Now that means that it has basically CO, and it has total of 4 compounds of 4 carbons, so it might be CH3 here, CH2 here, CH3 here, or it could be the other way around, like CH3 here and the rest on the right side. But that doesn't change the fact that this is butanone. So we'll just name it. So butanone. Now make sure that if you name it, that's fine. But if you write the formula, you write the full structural formula like this. Do not write the molecular formula because they have specifically asked for structural formula. A can be reduced to compound B. Of course, ketones can be reduced by using a reducing agent. We know about two reducing agents, NaBH4 and LiAlH4. So just pick anyone. NaBH4 is easier to solve, easier to use. LiAlBH4, LiAlH4, which is explosive in presence of water, is slightly more difficult to or dangerous to handle. But they will both reduce it to secondary alcohol. And when that happens, it's going to become CH3, CH2, COH, CH3. Okay, so that's the formula, structure formula. Okay, next question. 2-hydroxypropanoic acid can be prepared in two-stage synthesis from ethanol. So we are starting from ethanol. What are we doing? We are basically adding a carbon to the chain. And to do that, we need nitrile. They have already mentioned that you have HCN in presence of NaCN catalyst. So we have nitrile coming in, which will obviously increase this. And then we have to, let's write down the equation. So I start with this compound CHO. Let me just draw it out. Okay, so this is the compound. I add HCN to this. So HCN adds in a way that this is basically going to attack, the cyanide is going to attack the carbon. That carbon, let me show you. So this cyanide ion with the negative lone pair is going to attack the carbon because carbon has slightly positive charge. Because of that, you're going to get this carbon with the CN with it. And now the oxygen will get the electron and get a negative charge. Now H positive will be attacked by that oxygen and it will become OH. So that's what we get here. And of course on this side you still have hydrogen and on this side you have still CH3. Okay, that's the first step of the process. Of course this is not the final step because this cyanide must give way to make carboxylic acid, which is basically going to happen through hydrolysis. So what type of reaction is this? When they ask you about type, they're basically asking you about is it addition, and when they ask you about mechanism, they are asking you about telling nucleophilic addition or electrophilic addition or substitution or what it is. So this is nucleophilic addition. Why nucleophilic? Because this is attacking carbon first and the nucleophile CN is responsible for doing that. Why is it addition? Because there's a double bond that's going to be broken. So yeah, this is nucleophilic addition. Now they're asking us for the mechanism of this reaction. So that's pretty straightforward. So here's how it goes. So we start with getting the double bond like that in this. Whenever you have double bond, whether it's alkenes or whether it's any other compound, just make sure that you draw it in the standard form so that you can easily show whatever's happening. And then I have the hydrogen, I have CH3, that was my original compound. There are those partial charges. So there's the partial positive charge here, partial negative charge here. Now there's also going to be a nucleophile, which is CN in that case. Let me just write that. So CN. So it attacks from the carbon side with a lone pair. This lone pair attacks it. Make sure you draw a curly arrow. When it comes close, this oxygen gets that the two electrons. Now this forms what? So this is going to form, the oxygen has gotten a lone pair with a negative charge and this has gotten CN. Obviously there's a nitrogen with a lone pair, but we don't need to mention that. And now you have hydrogen here and CH3 here. Okay, now HCN, which we had, is going to be attacked by this lone pair. So there's again a slightly positive charge here, slightly negative charge here. Wait a minute, that's not the case because carbon and hydrogen bond is non-polar. But in any case, this basically attacks this, and when that happens, you're going to get H added to this. So that gives me what? OH here, CH3 here, H and CN. And of course, I'll get CN produced as a response to this because H has been added. So yeah, that's how you get. So this HCN basically breaks down into H and CN, and that CN is regenerated, as you can see, and that is why this is a catalyst. In the second stage, the product from A is converted into lactic acid. Write the equation for this reaction. So lactic acid was the acid that they gave us. So we start with this thing, CH3, what is that? C, then there is H, and there is OH, and there's this CN. Okay, and we'll hydrolyze it because we want to convert it to acid. Okay, and hydrolysis always happens in presence of H positive because we want an acid to be made at the end, so H positive there. Okay, we could have OH negative, but that will not produce carboxylic acid at the end. It will produce some basic compound. It will produce an ion, but let's see. So the CH3CH, nothing happens to OH because this is not really acting as an acid here. Some alcohols do act as acids, weak acids, but that's not happening here. You're already in an acidic medium. This carbonyl, however, will be oxidized, will be hydrolyzed to carboxylic, and the ammonia will be made from nitrogen. Nitrogen gets ammonia, but that ammonia in presence of H positive does not stay as ammonia. It becomes NH4 ammonia. So the H positive is taking care of that as well. Now we have to balance it out. H positive is being given to the ammonia, but ammonia is made by taking what? NH3, so 3 hydrogen there, and COOH, 1 hydrogen there, so I need 2 water. Yeah. Say what type of reaction is this? This is hydrolysis. Okay. In this instance, 4.4 grams of ethanol were used. At the end, 5.4 grams of lactic acid were obtained. Okay, so let me figure out the moles. Okay, so moles of ethanol is 4.4 over its MR. MR is CH3CHO. That is 12, 3, 12, 1, 16. Add them all up. So that is 44. So yeah, 0.1 moles is what I have. Okay, and mole ratio. What's the mole ratio? I can see this 1 to 1, so I should get so lactic acid 0.1 mole as well. So 0.1 mole is what I need. Now the MR of lactic acid. Let's see over here. This is 15. This is 16. Sorry, 13. This is 17 plus this is 12 plus 16 times 2 plus 1. Add them all up. Let's see. So 15 plus 90. Yeah. So MR is 90. So mass made is 0.1 times 90, which is 9 grams. So I should get 9 grams if it was 100% efficient, but that's not the case. I got only 5.4 grams. So 5.4 over 9 into 100%, and whatever that answer is. 9, 6 are. Okay, so 60%. Yeah. Okay. What's happening here? A student obtained the following results when analyzing an organic compound. H, okay, relative molecular mass is 72% is this. ये भी हमने देखा था. Br को decolorize करता है. That shows this is unsaturated. Okay, it is acting as an acid. Okay, reaction with can be oxidized. Okay, so can be oxidized. This is the information we're getting from this. No reaction with DNPH, so no carbonyl bond. Okay. There are 5 different compounds. No, wait a minute. This is 1H, right? Yeah. So let's see. So this is all we know about this molecular formula. We did it. अभी हमने किया था. उसमें क्या आया था? ये वाला था. C4H8O. So that's, I'm just copying that one. So C4H8O. Okay. What can we deduce about the nature of H by the following test? So we just did. वो मैंने आपको लिख दिया यहाँ पे. ठीक है. So carbon carbon double bond because of bromine and oxidation की वजह से OH and acid obviously weak acid है तो वो भी OH की वजह से हो सकता है. What function group would have given a positive result in test 6? Test 6 क्या था? Carbonyl. So you write carbonyl. And what function group is shown to be present by 5 and 6? Let's see. So 5 and 6 together. 5 में उससे ऑक्सीडाइज किया और उससे हमारे पास जो बना. Okay, so this must be an alcohol. Can be oxidized, yes, but doesn't have carbonyl. So this is primary alcohol. Secondary भी हो सकता है. 5 and 6 को अगर हम देखें तो primary secondary दोनों हो सकते हैं. Okay, on testing a sample of H, the student found that this was not chiral. H did, however, show cis-trans isomerism. How does cis-trans isomerism occur? So cis-trans में क्या होता है? You need a double carbon-carbon bond, and you have different groups attached to the carbons. So you have different groups, and the reason, how does it happen? The reason is that this carbon-carbon double bond has a limited rotation. Okay, so limited rotation around carbon-carbon double bond, which is why cis-trans isomerism occurs. इस क्वेश्चन को समझने में ज़रूरी है कि cis-trans isomerism आता क्यों है. इस वजह से आता है कि हमारे पास रोटेशन लिमिटेड होती है. हाँ, वो होता क्या है? That is when it has a double carbon-carbon bond and different groups attached to the carbons. दोनों कार्बन्स को different groups attached होने चाहिए. ऐसा नहीं हो सकता कि एक को same group से attached हो. Use all the information above to draw labeled displayed formula of the stereoisomers of compound H. Compound H में क्या था? C4H8O, और हमें पता है कि प्राइमरी अल्कोहल है. प्राइमरी अल्कोहल होने का मतलब ये हुआ कि उसके पास COH है एक साइड पे, और CH2OH होगा ऑब्वियसली, या CHOH होगा, वन ऑफ द टू. ओके, नहीं, CH2OH होगा या CHOH अगर डबल बॉन्ड वहाँ पे आ जाती है. लेट्स सी, कार्बन कार्बन डबल बॉन्ड लगा दी हमने. ठीक है, इन कार्बन को हमने डिफरेंट चीज़ों के साथ अटैच करना है. इट हैज़ टू बी प्राइमरी अल्कोहल, सो यहाँ पे लगा देते हैं OH. ऑब्वियसली HH यहाँ पे फिल भी करना पड़ेगा. एंड टू गेट cis-trans isomerism मैं एक काम कर सकता हूँ कि यहाँ पर इसी जगह पे कार्बन लगा देता हूँ. अब ये हाइड्रोजन बन गया, हाइड्रोजन, ये cis है. ठीक है, दिस इज अ cis isomers. To get the trans, I can just cross multiply them and bring them like that. So this stays at CH2OH, and this one becomes H, this one becomes H, and this is CH3. So this is trans. ठीक है, तो हमारे पास ये get दो. Okay, let's do another question. Compound Z, an organic compound with 3 function group, has the molecular formula this. Okay, the function group can be determined by the following test. Test for function group Z decolorizes. That means इसमें double bond है. So this is carbon carbon double bond, या आप इसको alkene बोल सकते हो. Test for second function group. Z reacts with sodium to give hydrogen. That tells me it's an alcohol because it's a weak acid. Solid compound formula of this. So sodium whatever ester बन गया हमारे पास. ठीक है. उसके बाद क्या है? कार्बोक्सिलिक एसिड भी हो सकता है, ये OH होना ज़रूरी नहीं है. ठीक है, अच्छा ठीक है. आगे, when Z is heated with ethanoic acid and a few drops of concentrated sulfuric acid, a sweet smelling compound. तो इसका मतलब है ये COOH नहीं हो सकता. It has to be an alcohol because that's how you make ester. Sweet smelling compound is an ester. What function group? So it is OH, which is alcohol. Test for third function group. A few drops of Z forms a yellow-orange precipitate when added to 2,4-DNPH. ये carbonyl की बात हो रही है. When a few drops of Z are warmed with tolerance agent, silver mirror is formed. Carbonyl के अंदर हमारे पास दो ऑप्शन हैं, एल्डिहाइड और कीटोन. तो अभी तो ये दोनों हो सकते हैं, लेकिन when we read the tolerance agent one, that tells me it is aldehyde. It can't be ketone. Okay, so judging by that, I know this is aldehyde, या जिसको हम HO group बोलते हैं, CHO group. ठीक है, अच्छा, Z does not show cis trans isomerism, मतलब इसमें डबल बॉन्ड जो है वहाँ पर डिफरेंट ग्रुप्स अटैच नहीं है। डबल बॉन्ड होना ज़रूरी है क्योंकि वी ऑलरेडी नो डबल बॉन्ड है, बट डबल बॉन्ड पे जो कार्बन है उस पर दोनों हाइड्रोजन लगा दो या दोनों CH3 लगा दो, तब जाकर हमारे पास सिस ट्रांस आइसोमरिज्म खत्म होता है, वो नहीं होना चाहिए। अच्छा, तो इसको डबल बॉन्ड लगा देते हैं, ठीक है। अब हमारे पास टोटल 4 हैं, जिनमें से एक एल्डिहाइड भी होना ज़रूरी है, जिसमें OH होना भी ज़रूरी है। सो 4 है ना, ठीक है। इसको ऑक्सीडाइज कर देते हैं ऐसे, इसको OH कर देते हैं। नाउ मेक श्योर दैट व्हेन यू आर ड्राइंग इट, इट्स वेरी कॉमन मिस्टेक है वो लोग O और H की बॉन्ड नहीं शो कराते हैं, तो ये होना ज़रूरी है। अच्छा, एक ये बन गया। अब इसका हम सिस ट्रांस तो हो नहीं सकता, कोई और करते हैं। ये चीज़ ऐसे रहेगी, हाइड्रोजन हाइड्रोजन, इधर भी हाइड्रोजन था। अब यहाँ मैं एक काम कर सकता हूँ कि एल्कोहल एक साइड पे लगा देता हूँ कि ये एल्कोहल लग गया, एंड आई कैन पुट दी कार्बोनाइल ऑन दिस साइड। यप, आई थिंक दिस विल वर्क, या दिस शुड वर्क। सो या दैट इज इट। तो हमने ये भी कर लिया। लेट्स मूव ऑन। In parts E and F, you may use R to represent the part of the molecule that does not react. Okay, what is the organic compound formed by the reaction Z in each test in B? ठीक है, सोडियम के साथ क्या हो रहा है? हमारे पास Z है क्या? इसी को उठा देते हैं। कहाँ पर है? सोडियम के साथ रिएक्ट हो रहा है ना, तो ये है। तो इसका मतलब है सोडियम के साथ रिएक्ट होते हुए तो सोडियम आएगा और H रिमूव है, दैट मीन्स इट इज द अल्कोहल पार्ट दैट इज रिएक्टेड, तो O उसका आएगा और R वो जो रिएक्ट नहीं है। बेसिकली हमारे पास R है जिसका OH लगा हुआ है और उस O H के बीच की बॉन्ड टूटी है और हाइड्रोजन की जगह सोडियम आ गया बिकॉज इट्स कैन डिस्प्लेस इट, इट्स अ वीक एसिड। सो दिस इज व्हाट वी गेट विद एथेनोइक एसिड के साथ हमारा यही अल्कोहल वाला पार्ट मूव करेगा। सो ROOCH3C, ठीक है, दैट्स द वन वी आर गोइंग टू गेट विद अल्कोहल। ओके, और यू कैन आल्सो रिवर्स इट, यू कैन से CH3COOR, दैट्स व्हाट वी आर गेटिंग। ठीक है, उसने हमसे फॉर्मूला कोई भी लिख सकता है। अच्छा, draw the structure of organic compound Z formed in each of the tests with tolerance reagent। tolerance reagent में होता क्या है, आपके पास जो aldehyde group है वो ऑक्सीडाइज होता है और वो एसिड बनाता है, but then that acid itself reacts with the ions that are present in there, giving you RCOO with a negative charge, क्योंकि जो H पॉजिटिव है वो लूज हो गया। with 2,4-DNPH के साथ हमारा what is this thing? That is 2,4-DNPH। तो हमें इस कॉम्पाउंड को उठाना होगा, ठीक है। ये हमने पहले भी इसको देख चुके हैं। 2,4-DNPH में होता है बेसिकली ये कि आपके पास CO है ना, ये CO है, तो दिस बॉन्ड बेसिकली ब्रेक्स फ्रॉम हेयर एंड द कार्बन जॉइंस द नाइट्रोजन दैट यू हैव हेयर, तो H2O बन जाता है। सो टेक्निकली व्हाट हैपेंस इज दैट दिस H and this O they form H2O and the remaining part is joined together, so you'll just take that thing और इसको आपने join करवा देना, ठीक है। so yeah, take that thing, इधर कार्बन से join होगा और उसके आगे R है क्योंकि वो कुछ भी हो सकता है, and put the remaining thing। now notice कि आपकी structure maintain रहनी चाहिए जो भी उसने बनाया हुआ है। okay, so just notice that H2 and O are left out, this is like condensation happening and the carbon bonds with the nitrogen। But2-enoic acid, enoic acid का मतलब है कि इसमें डबल बॉन्ड है। इज एन आइसोमर ऑफ Z which shows cis trans isomerism। तो C का cis trans isomerism शो कराने वाला कैसे होगा, इनको आप डिफरेंट ग्रुप्स अटैच कर दें, एक साइड पे कार्बन वाला कर दें, कुछ इधर भी कार्बन वाला कर दें और इधर हाइड्रोजन्स कर दें, दैट्स हाउ यू शो cis trans isomerism। ओके, सो दिस इज cis because hydrogens are both on the same side। अब हमारा C4H8 C00 था ना, सॉरी C4H8O2 था। अच्छा, तो यहाँ पर हम एक साइड पे हम कार्बोक्सिलिक एसिड बना देते हैं, और एक साइड में मीथाइल बनाया था, C4 कंप्लीट हो गया। Z का ये फॉर्मूला था ना, इनोइक है तो उसके बाद डबल बॉन्ड आएगी, तो बस बन गया। एंड या दैट इज द, चलें एक क्वेश्चन और कर ही लेते हैं। ओके, विच वुड, वो क्या था, commercial paint and varnish removers contain a mixture of chloromethane and methanol. Okay, what will be the observation when the following reactions are carried out in each case? ठीक है, chloromethane is reacted with sodium hydroxide and silver nitrate, and the mixture left to stand. The important bit to remember here is chlorine, silver आ गया। silver का मतलब ही क्या है कि वो उसको टेस्ट कर रहा है क्लोरीन को। हेलोजन के टेस्ट के लिए हम सिल्वर आयन यूज करते हैं। So with chlorine it forms AgCl. AgCl is white precipitate. That's what we'll get. This is not related to carbonyl as such, but maybe कोई part उसका हो। CH3OH is mixed with PCl5. PCl5 के साथ जब ये रिएक्ट करेगा तो हमें बहुत से प्रोडक्ट्स मिलेंगे, जिनमें POCl है, जिसमें HCl है, जिसमें CH3Cl है। तो इस वजह से I think this one is going to be HCl because that gives us the observation. बाकी दोनों तो solvent में dissolve हुए होंगे। HCl is going to be giving us white fumes, and those fumes are coming from HCl because it is a gas at room temperature. Don't call it hydrochloric acid, it is hydrogen chloride without water. CH3OH is reacted with sodium. Sodium dissolves, hydrogen gas comes out, so we'll say that bubbles of gas pops in a flame. That pops in a flame. And the gas name is hydrogen, so H2. Okay, this one's easy. I'm going to skip this one. You just have to show the empirical formula. And yeah, let's look at this one. क्या हो रहा है? Compound with empirical formula CH2O can have molecular formula. ठीक है, उसने डबल कर दिया उसको। Two possible structure formula for the compound with molecular formula this are ethanoic acid. No, this is not ethanoic acid. This is a methyl methanoate and ethene diol है, ये तो दो OH हैं, so eth1 diol with an ene, ethene 1 diol, ये बनेगा। In the box below, draw displayed formula for 3 further structural isomers. Further structural isomers क्या होते हैं? कार्बन का डबल बॉन्ड तो होनी है, ठीक है, और H4O2 है, तो H4O2 का मतलब है कि या तो आप कार्बोक्सिलिक ग्रुप बना सकते हैं या आप 2 अल्कोहल बना लें, ठीक है। तो फुल डिस्प्लेड फॉर्मूला के लिए यहाँ पे बॉन्ड होना ज़रूरी है, सो विल ड्रॉ दैट बॉन्ड। अच्छा, अगर वो नहीं बनाना तो कार्बोक्सिलिक बना लें। कार्बोक्सिलिक का COH हो गया तो पीछे CH3 बच गया, एथेनॉइक एसिड बन गया। अगर वो नहीं बनाना तो आप एथेनॉल बना लें। कीटोन नहीं बन सकता इसका बिकॉज यू डोंट हैव, सो ये लें, हियर यू गो, 4 carbons 2 hexane, सही है। Identify which of your compounds will react with the following reagent. NaHCO3. NaHCO3 क्या है? NaHCO3 is acid as well as base. ये हमारे पास एम्फोटेरिक सॉल्ट है क्योंकि इसमें हाइड्रोजन आयंस भी हैं और कार्बोनेट भी है जो कि बेस के साथ रिएक्ट करता है। तो हमारे पास कोई एसिड तो है ना, यहाँ पे एथेनोइक एसिड है, सो दिस इज गोइंग टू रिएक्ट विद, बेस नहीं है हमारे पास, so this is going to react with Y and this is going to produce what? Carbon dioxide, so effervescence. You can say effervescence of gas that turns lime water milky if you want. Tolerance reaction reacts with aldehyde, so that is Z, and the observation is that it gives us a silver mirror. Okay, that's tolerance reagent. Failing solution होता तो वो red precipitate देता। One of the 3 compounds shows stereoisomerism. Stereoisomerism कौन सा होता था? Cis trans isomerism को stereoisomerism बोलते हैं। So double bond but both sides with the same group, that is this one. This is cis at the moment. So हम इसको copy करेंगे। Okay, and now we'll draw the trans And there you go, we have drawn it. And yeah, that I guess is the end of this worksheet. Make sure that you solve these questions, use the weekend. Or carbonyl is a challenging concept because it's new, not because it is difficult. It's new for most students, so इसलिए वो थोड़ा सा problem होता है. So make sure that you practice this. Make sure that you don't waste the weekend. Allah Hafiz.